All right. Well, thank you, everyone. It's a pleasure to be among such great company. I'm here presenting Beyond the Benchmarks. I represent Remix AI. I'm one of the co-founders, and we are building AI agent-guided ML development platform. So if you want to, on your spare time, you can check this out. But I think the topic for today should be kind of a culmination of all the stuff that's been happening in this awesome conference. And hopefully this kind of helps wrap some of those ideas together. So if you pay no more attention to the rest of this talk, these are the key takeaways I'd love to leave with you. Some of those are quality and evaluation are essentially the same, two sides of the same coin. They're very much related, and you want to keep them in mind throughout the entire process of the ML development process. You also want tailored evaluations at all stages of the development process. So not just post-training a model once you fine-tuned it or anything like that. You want to have different kinds of systems that could evaluate the process all through the data curation process, the model selection, training, and then deployment. And then another sad but very true truth is that offline metrics often don't line up with online metrics when you're deploying an AI application. So what you want to do is be able over time shorten that gap between the two so that you have a good way to measure if you're going to be successful in your AI development early on. All right. So some of the lessons that we've learned in the past in ML development and other industries, I think, are very much applicable now to being able to develop Gen AI applications. And that's following the scientific method to developing applications. And kind of what does that look like? You want to start first by identifying what problem you want to go ahead and develop, or what solution you have in mind that could help essentially lift the KPIs for your business. One of the big themes in this talk will be how do you align what you're building, your goals in development to align with the goals of the business overall. You want to make sure that you bring value and that the applications you're developing are very much aligned with that, both to make a sustainable AI product over the long run and obviously to help out the business, right? Everybody's looking for that. So once you identify a potential solution, you want to bring a hypothesis about what will happen if you develop and you deploy that application. It might be, hey, if we make this chatbot more empathetic, we think that there's going to be less people bouncing off of our application and we're going to lift traffic. So a hypothesis about what you think will happen that will then impact your downstream KPIs. In the offline section, you want to make sure that you gather different kinds of attributes, skills, or qualities about your application that you think could impact those downstream metrics, right? You want to make sure that those are aligned over time. And the idea here is because online metrics are a bit expensive, you kind of want to justify why you're developing what you're developing and why you think it's going to impact the downstream tasks. Once that's justified, then you can move forward to an online evaluation. So you expose it to your users or online, and then hopefully you get a validation or even a rejection of your hypothesis. So you get to learn essentially how to improve that application. All right, so how do you actually design these metrics? Also very, very vague in the Gen AI world, right? We can't rely on simple metrics like accuracy or ROC curves like you can with image classifiers or like that. So what's a good way to ground your development process into a positive change? So offline metrics can include different types like benchmarks. You can ground your selection process on benchmarks like ChatSys LLM or the Chatbot Arena. You could also use LLMs themselves as judges to then be able to identify skills or gaps in skills gaps in your application. And these can be also used both in model selection, model training, and data curation. Emphasis on all kinds of processes you could use these solutions instead of just at the very end. And online metrics, these are kind of the big time metrics, the kinds of, I think, behaviors that you only see once you deploy an application. For example, whether your app increases the viewing time on a streaming platform, right? Or if it increases the ability to close a sale if you're doing an e-commerce kind of company. This may look like human evaluation, so folks who are actually going into the app and then manually reviewing, is this good or is this bad? or A/B testing, where you're separating your users into cohorts and then exposing them to different versions of your model or your application and seeing how they respond. So again, this is more expensive, so you want to save this till the end. You essentially want to use those offline metrics to justify being able to make an online test. And how do you actually go about designing offline metrics? I think you want to start, again, closely aligning with the KPIs. What are you actually driving towards? If it's increased time on streaming and being able to view ads over time, maybe you need to improve the recommendations of the videos or the content that you're showcasing. And then you have hypotheses about, well, what makes good content? Maybe content that is exciting or interesting, exotic, all kinds of other skills or attributes that you can then start brainstorming and then put to the test. And then you also want to define requirements for your application. So not just how they'll behave actually being deployed, but maybe even constraints on the engineering side about how your application should be designed. So say that you have constraints of an LLM RAG-based system, and maybe that needs to be on-prem, or it needs to be locally because you have your GPU poor. You can't afford very large models to be deployed. So maybe some of your criteria would be finding models that are performant at the 3B to 8B parameters. Maybe you want to make sure you can use PEFT, so parameter efficient fine-tuning techniques like LoRa. And possibly want to see if you can also quantize, and then also make sure you can use that model permissively. So I think theme of this time and time again, even though in classical machine learning and also beyond in generative AI, we still haven't moved away from the main components, which is data, and data quality over trumps quantity. So you want to make sure that the quality is as high as you can get it, and you may not get it right the first time when you deploy an application. That'll take time over iterations and deployments. You'll get more clues. Ooh, did I lose my screen? I must have. Sorry about that. Are we back? We're back. All right. So you want to make sure that essentially you get great metrics offline and then online so you can learn what makes a good data sample that you want to then use to improve your application. And some hacks that you could use too, which are materializing in a bunch of different works, are data synthesis is a big area to explore. I highly recommend that. And then also indexing. So there's a way to be able to take a really large data lake of resources and then filter that down to the best resources that you can think of, or the best samples. And they may be samples that you synthesize because you understand exactly what that data should look like, or maybe it's stuff that you've learned from the wild after you deployed your application. All right, I think I'm also losing track of time. Almost done. And generally speaking, when you're developing this, you also want to make sure that you build trust with your organization. As an engineer and a developer, you probably know all the ins and outs of the systems you're developing, but it's kind of hard to translate that to folks who are maybe more decision makers or at the business level. So another great reason why trying to align your offline metrics to be as close or as predictive to your online metrics makes sense here. Essentially, you can show how your offline metrics are evident points that help you say that the online metrics that we actually care about, like that streaming time or viewing time, is actually going to go up. And that means plus dollars. Or maybe productivity is going to be higher, so it means less time spending time processing something, so lower TCO. All right. So again, hammering at you, but measuring at every stage is super useful and helps you catch problems early on. You can design your system with the most evidence that you might have, and then over time iterate and feed that back to the very beginning process. So feed that back to your data curation, to your model selection, once you understand how the system should behave for fine-tuning, and then also deployment. And also, big fan of version control, hence why I'm super big fan of Docker. Big advocate for being able to use tools like this to essentially capture everything about the environment that you use to develop your applications and then also to deploy them. The data assets. There's been cases where I've had customers that I've worked with that, something in their data lake changed, and so now they can't tell why their application doesn't work anymore. So that's a loss of time and also loss of money, as well as just the typical things that you might log about an ML experiment, like the parameters, the architectures you're using, the versions of those checkpoints, all that good stuff. All right, and that's me. I'd love to connect with all of y'all. Center one is for the remix site, and on the left-hand side is me, and then right-hand side is my co-founder. So love to chat more with y'all.